The first is the sample execution scheme. This is the regular measurement and histogram we expect to receive from the execution of a quantum circuit. We will design our model with some parameters, and only when we code the execution scheme to the model, we will pass the parameters. The second is an hybrid execution scheme, called the VQE. It is originated from the variational quantum eigensolver algorithm, which we reviewed in a previous session. We will use it as a general variational scheme, where we will design our model with some parameters and ask Classiq to optimize these parameters according to some loss function. So let's start. Our example for both execution schemes will be a simple Ry rotation over one qubit. First, we initiate our model. Then, we define our building block, which is the Ry gate in this case. This gate expects to receive one parameter. And now we will just define the parameter as a string. This will be our variable. Next, we need to wire the building block into the model. And finally, we need to define the sample execution scheme. Here, however, we need to pass to the execution scheme what are the parameters the model should synthesize it with. So we define our execution parameters as a dictionary, where the keys, or the key in our case, are the parameters themselves in the form of strings. And the values of the dictionary are the values we want the model to substitute, pi/7 in our case. Then, we define the execution scheme to be sample, as usual, but now we pass to the model the execution parameters to be substituted. And that's it. Now we can continue as usual and to synthesize the model, and even to execute it and review the results. So this is the first way to pass parameters into the model. This can be useful if we have some pre-processing to do, some intermediate calculations, or a loop where we want to substitute many parameters within. Let's go ahead to our hybrid execution scheme now. Firstly, we define the Ry building block and wire it to the model as before. We still pass it the parameter in the form of a string, and we call it x as before. Now comes the cool part. Instead of just sampling the generated circuit, we set the execution scheme to be a VQE. The first thing we need to pass to the VQE scheme is the Hamiltonian we want to minimize its energy, or we can view it as our loss function. We need to pass the Hamiltonian we want to minimize in the form of Pauli list. In our example, we choose the Hamiltonian to be a sum of the z and x Paulis with the coefficients 1 and 0.1 respectively. Here we can see the Hamiltonian's matrix representation. Next, we need to define in the VQE scheme what's the maximum number of iterations we want to have for our hybrid model. Lastly, we need to choose our classical optimizer. And that's it. Now we can synthesize our hybrid model, execute it, and view the results. Specifically, we can see what is the optimal parameter, which is the optimal angle of rotation for minimizing the Hamiltonian we chose. This brings us to the end of this video, to the end of this lesson, and to the end of this first Classiq bootcamp. We hope you enjoyed it so far, and that now you have the capabilities to master the Classiq platform.